More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at home. Real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at home is right for your child, visit mathnasium.com/at-home. Mathnasium at home, changing lives through math.
Hi everyone, and welcome back to Mathnasium Schoolhouse. I am Sandra, your instructor for today. And today we're going to be looking at numberless math problems. And I wonder how many of you are maybe intrigued by this topic, and maybe that's what brought you here, is how can we possibly have math problems without numbers, which is essentially what we're looking at today. So I'm curious to see from you guys, what do you think that this topic we'll look at today? And maybe the best way that you can kind of leave your comments for me is to just give me a problem. Think of a problem, a math problem, a word problem, that's what we're sticking with today, that does not include any numbers, but we still have to perform some, let's say, computation, some calculation. We have to use some operation that we know about from our math class to find the answer. So go ahead and maybe share that with me. I'm interested to see how many of you can maybe think of one. We'll see several today that we'll practice with. Hello, everybody. Love to see you guys pouring in, saying hello before I even ask you to. Going into 4th grade, I'm seeing 6th grade, 5th grade. The beautiful thing about today's topic is it's wonderful even for adults, for adult math learners that still wants to practice a lot of just their math muscles, right? And just understanding that behind all of the calculations that we do in math, there is a deeper understanding that has to be there with how to manipulate the numbers that we're working with. And that's really all about, that's really what number sense is all about when we talk about that at Mathnasium. And so that's what we'll be working with today. So once again, I'm going to pose a challenge to you all as we wait for more people to pour in, to just share with me a math problem that doesn't involve any numbers. Let's see if I could at least get one. I'm looking at the comments. A math problem that doesn't have any numbers. Try to think of one and share that with me. 7th grade, wonderful. All right. Let's see who can give me one. Hello, hello. Okay. And if that's maybe too much of a challenge for you, let me pose this question to you again, just as we wait for more people to pour in. I want you to think about the name Mathnasium, right? We keep on hearing it. We're here on Mathnasium's national Facebook page. What does it remind you of? What word does it remind you of? What do we do at Mathnasium? Okay, I see x plus g equals b. Oh, I like that. That's some smart thinking right there. So using our knowledge that, especially as we approach algebra, in our math learning, letters, right? That's the whole joke out in the world. Letters start to appear, alphabet starts to appear in our math class. Yeah, that's very cool. I like that. And it actually brings a lot forward to what we're going to be talking about today, right? Is that these letters that we bring in, these variables is what we call that, refer to them as in our math class, represent something, right? And just our understanding of that helps us solve any problem with any numbers. So that's beautiful. Okay, cool. I'm not seeing any necessarily come in. Oh, I see a quarter of a circle. I like where you're going with that. Yeah, we could absolutely use that knowledge and kind of put numbers to that, knowing what a quarter is. I like that. You guys are giving me a lot of variables. Perfect. I like it. So what I want to get to today is really, as I said, Mathnasium stems from this idea that we're the gymnasium for our minds. And I think that that's so beautiful to put together for math students, is that you're still exercising muscles when you're doing math, right? Maybe it's not physical workouts, but what I'm going to show you here is if you've been at a Mathnasium, I just have a poster here that's been in my house for a while, but you'll see these figures all around our center walls. And these are some of our newer art, so if you're lucky enough to get into the center now, go ahead and check them out because they're just stunning and beautiful and so cute, to be honest. But you can see that they're geometric shapes, and I know it's a bit blurry, but they're geometric shapes performing these sports or these activities, again, showing that we're really exercising, right? That's what we're doing in our math class. So today, when we look at numberless word problems or numberless math problems, I want to dig deep with all of us into seeing if we truly understand what we do when we solve a word problem, okay? So instead of just looking at the numbers and jumping to what we assume has to happen, let's really make sure there's a deeper understanding there. So let's maybe review what we know about word problems. So I'm going to pose a word problem to you. I'm just going to pull one up for myself here. Hello, everybody. I'm going to pull one up and I'm going to read it out to you rather than just writing it out for now. So try to pay attention as I say, and then I'll write down some of the important information in just a second. So what if I asked you, very simply, there were 16 mice, right? So there's 16 of these mice that are playing in a huge field, okay? And then maybe an hour or two later, 8 more mice come to these initial 16 mice and start playing with them. How many mice are in the field altogether? I know for some of you that are maybe in middle school, this might be a simple problem. Nonetheless, help me understand how you would solve this problem. Okay, so let me write down some of that important information, because typically when I see a word problem, I first listen to it, I read it, whether I'm hearing it or reading it. I listen and read the whole thing, and then I think, okay, what's this important information here? Well, at first, I have 16 mice. Making sure that's appearing on the screen. 16 mice. Oh, I see the answer. Very good. And then I have 8 more mice come to play in the field. Okay. So how many are there altogether? And that's important for me to know because that also helps me think what operation I'm doing here. Or performing, I should say. And I see you guys already using the operation. Yeah, I love that. Someone commented back and saying, we love to see your equation, right? Exactly how you came to your total answer of 24, which I'm just going to write down because I'm seeing it appearing. So thank you for that. It is 24. And how did you know to add the 16 and the 8? Well, maybe what you learned from your teachers at school or maybe from an instructor at Mathnasium is that when you see keywords, right, once you identify the important information that the word problem gives you, you identify some keywords that hint at what operation you're going to use. And possibly what you saw here was more, right? So I had some amount, and to be honest, I don't care what that initial amount was. This could have been 160, 1,600 mice. It's just 16, but the fact is some more mice came to join the party, right? Again, I don't care how much for now, because I just need to dig deep and truly understand what I'm doing in the first place. I don't want the numbers to mess me up. There were some initial mice, some more came. How many altogether? And you guys are doing it beautifully. You're telling me exactly what I want to hear, which is when I'm looking for how many are there altogether, I am looking at how many there are now all in the field, which means I take that initial amount and add the amount that came. Altogether means addition. You guys are telling me more and add. Perfect. Love it. So you've definitely had 1 or 2 lessons where you've looked at some keywords and identified what operation to use. Maybe it's addition, subtraction, multiplication, division. So let me maybe ask you some of these and see what you can tell me. I'll number them so you can number it in the comments that you provide me. So let me erase this. So for now, we should be on the same page of how to at least approach a word problem. I know that sometimes they can be intimidating, especially when they get to be lengthy paragraphs. But what I want to help you get at today is sometimes if we just ignore the numbers, we come to a better understanding of what the question is actually asking us, which just, the reason I point that out is it just seems so absurd at first thought, right? How can you remove numbers from a math question? But I promise sometimes it actually makes things easier. So let me actually ask you here, I'm going to write down some keywords, and I want you to tell me what operation you would use here. So let's say I wanted to know how far apart. Tell me, am I using addition, subtraction, multiplication, or division? And you can number them. You can say number 1 is whatever operation. Let's see, what if I asked you, in a word problem you were looking at inside of that. Okay. Let's say I asked you to find the total. This one might be a bit tricky, this number 2, but I'm curious to see what you say. And then let's say I asked you to find twice of something. I'll leave it at those 4. And I'll tell you that each of them is a different operation. So go ahead and share what you think here. I'll wait to see some comments. Number 1, I'm seeing some answers come in. Okay. Ooh, I see someone got number 2. Very cool. I like that. Very nice. I'll wait to see a few more. So again, what I'm getting at here is that sometimes you'll have some word problems where these key words, key terms, key phrases are used, and they're there to help you know almost automatically what operation you would use, or at least to reason out what operation would be most beneficial. Okay? So let's see, what if I had a word problem and they're asking even how far apart are 2 people standing in a line? Okay? What would I possibly do? I'm looking for subtraction there. So let me just draw this symbol. So I'm looking ideally for subtraction, but maybe you can correct me and think of a word problem where if we use this phrase, I see that a lot of you said addition. Maybe you have a good example and you can definitely offer that to me. Okay? Sometimes in the English language, we can manipulate things and they can mean so many things. So if you think math is confusing, think again. It's really the English language. So what if I had inside of that? This one's a bit of a tricky one, but I'm going to tell you, this typically will tell you that you need to perform division. Okay? That's not too much of a popular one maybe in your math classes, but in Mathnasium we use a lot of this. Okay? Total, I'm hoping you guys got addition there, right? If I want to find the total of something, typically when you see that in a word problem, they're telling you to add 2 amounts together. All right? And twice, I believe I saw the word appearing. Yes, I'm seeing it for number 4. That's exactly right. And I know that in previous lessons with Kevin or John or Larry, anytime you saw the word twice appear, you're looking at possibly doubling, which means, yes, you can perform repeated addition, but we hope that you turn to multiplication as the fastest way to get to that answer. Okay? So a lot of the language itself will already tell you what to do with any numbers that you can then pop into your math problem. So now let's actually do some math. So I'm going to give you a problem. I'm going to erase this, and I really want you to pay attention to this problem. It's actually really fun. So my husband and I thought of this problem yesterday, and it was really fun because the way that I wanted to come up with the problem was to really get to the point that sometimes having numbers in a math problem maybe, and I don't want to say complicates things, but we get very, and I hope this is the right word, maybe obsessed with working with those numbers, right? We love math, we love numbers as a result, and so we truly try to do the math and get to it. We just get so excited. And sometimes with word problems, and this is why students sometimes find word problems challenging, is you really got to take a step back, read it, and analyze the information that's given to you and really decide what the best path forward is. And I promise once you train your mind to do that, then you'll have a better appreciation for word problems and you'll find it a lot easier. So let's say I have a deck of cards. I don't have a standard deck of cards here, but I have my Mathnasium deck of cards, so I'm going to use that in my problem afterwards when I tell you the solution. But let's say I have a standard deck of cards, right? Just the standard one for cards, okay? But I manipulate the amounts just the slightest bit. So I'm going to tell you what the new values are, okay? So instead of having 2s, 3s, 4s, 5s represent 2s, 3s, 4s, 5s, I'm going to tell you to pretend that now the 2s, the 3s, I want to mess this up, so I'm looking at the problem as we wrote it. The 2s, the 3s, the 7s now have values of 1 and a positive 1, okay? So let's say 2s, 3s, 7s are now, and I'll use a different color here. So I'm giving you some information where you're going to use it to find the sum. Okay. Oh, that's a great question that just popped up. What does manipulate mean? I apologize if that's too big of a word for some of you, and that's absolutely a fair question. It just means to change things around so they work better for you, and especially in a math problem. Okay. So let's say that then the 4s, 5s, and 6s, they no longer represent 4, 5s, and 6s. They have a value of 2. Okay. So for those of you that like puzzles and challenges and riddles, this is going to be really fun. Okay. The 8s and 9s, I'm going to tell you, now have a value of 0. And the 10s, jacks, queens, and kings have a -1, or sorry, I'm going to say -2. And last but not least, and I'll squeeze it in here, the ace has a value of -1. Okay. So what I want you to do is pretend you had this deck of cards with these values, and then you take this deck of cards, and let's pretend that this is the deck of cards. I shuffle it up, right? Just some random order. I'm not the greatest shuffler, but let's say you have someone shuffle it up. And you put the 2 aces right on top. So let's say I would find the ace. I would put them right on top, just 2 aces. And then I'm going to flip each card up one by one and add up the whole amount of the entire deck. Let me put that in the camera. Okay? And I want you to just tell me what the sum is going to be. I'm just going to give you a few seconds, okay, to just think about how you would find that. And if this is too much for you to compute because you haven't seen negatives, don't worry about it. Just think about how you might find it, right? How would you find this answer? I don't need you to get to the sum, just think about how you might. Okay? If I were to flip the cards up one by one using these values, what would be my total sum? So let's think about that for a second. Okay? What would we get? All right. So some of you might still be calculating it, which is perfectly fine, right? And then others might have already gone to an answer. There's a longer way to do this and a shorter way to do this. And what I'm going to tell you is, and you can go back to watch this lesson afterwards and pause it so you understand it a little bit or have enough time to come to an answer. But the answer you should get to is a sum of 0, right? And what I want you to notice here is that although this is a math problem, right, we're finding the sum. We're trying to find, once you flip the cards over and over and you add up all of the values, what do you get to? Like, we're finding the sum, but a lot of these numbers start to confuse us, right? We start to think, okay, I have the 2s, 3s, and 7s, and this was purposefully done, right? 2s, 3s, and 7s represent +1. But it doesn't matter if I had the 2s here or the 4s there at the top here, right? Because the fact is that I have 4 cards here, 4 cards here, 4 cards here, and if and I'm going to use this word again, manipulate, right? I'm going to add up how many cards I have altogether, maybe multiply by their value. I have one amount there, and I'm going to add up with the remaining amounts, and then I get to eventually a sum of 0. But what I want to show you is that sometimes this is unfortunately what happens in our math, right? Is that we're posed with word problems where the numbers completely throw us off, additional information throws us off, right? I told you that you can shuffle the cards and put the aces on top. To be honest, that doesn't change up your sum, because what we know about addition is that no matter what order we're adding it in, it's still going to get us back the same sum, okay? So I want you to start thinking about that, and maybe as you encounter different word problems, take that approach, that maybe it's a new approach for you as a strategy in problem solving and thinking what information is useful, what information is not useful, okay? So let's see, how could I have changed this to be a numberless word problem? Well, maybe instead, I could have just told you that I have some amount of cards that have now a value of 1, some amount of cards now have a value of 2, and so on. And then you would have thought, well, okay, now I need to find out how many of these cards I have so that then I can find a sum. But you would have had a few steps already up in your mind of how to start approaching it. So let's see how we can do that with some numberless word problems. And we'll go back to some of these number problems and see why numberless word problems can be more beneficial for us. So let's say that I'm going to give you this problem here. So go ahead and think about it. I have a preschool. Let me not even write that part. So a preschool is building a fence, okay? They have a playground and they don't want the kids to keep escaping, and so they want to build a fence around that playground, okay? It's going to be some number of, for my US students, yards long, and if you're a Canadian, you're my Canadian friend, you want to think of it as meters, whatever you're comfortable with. To be honest, it doesn't matter right now. You have a fence that is some number long. We'll talk about this in a second. And some number wide. Okay. So let me ask you this first. What lengths and widths for this fence would make sense, and what lengths and widths would not make sense for this fence? What do you think? And you can think about yards or meters, whatever makes you feel more comfortable, again, depending on what you're used to seeing. Okay. So go ahead and think about that. Give me some dimensions that would work for this fence. Some number of yards or meters long, some number of yards or meters wide. What would make sense? And let me ask you this. Would it make sense to have 1,000 yards long and 1,000 yards wide? What do you think? If you've practiced with your units of measurement, you might think right away, the answer might come to you almost right away. Does this seem ridiculous? Oh, I see a beautiful answer pop up. Let me get to that in just a second. What do you think? Is this a little bit ridiculous to have 1,000 yards long, 1,000 yards wide? To be honest, I'd say so, right? Even if this was meters for my Canadian students, yeah, that would be pretty ridiculous. But the answer, oh my gosh, just as I was going to ask the question, it popped up in the comments. How cool is that? Lorraine, and I hope that's the student's name as well, is asking, well, how big is the playground? And that's a fantastic question to ask. That's exactly what we want to know, right? Well, Sandra, I can tell you a bunch of dimensions that make sense in my mind because at the end of the day, I'm just making up numbers. But I need to know what area I'm actually working with for me to actually tell you, is it a reasonable number or not? So I love that that just popped up. 10 by 10, though, sounds honestly perfectly great as a size for a playground. So what makes sense in this situation, once we've thought about it, is a 10 by 10 fence, right? A 10 by 10 playground for the fence to cover the playground. So I like that. I'm going to put that down. So let's say, we're going to say 10 yards long and 10 yards wide. So what did we just do? We were posed with a problem without numbers initially, and we were asked to start to think about what numbers would make sense, right? And what if we had gone the opposite way? What if we were given some dimensions? I want you to stop and think about for a second, would you have thought about whether the length or the width makes sense? And if you do, that's wonderful. That's a great way to train our minds to look at some word problems and think, are the numbers that I'm working with actually reasonable? Okay, so try to get your mind used to thinking that way. And now let me ask you a question. So we're going to stick with this. This makes sense to us, 10 yards long, 10 yards wide. Now I want you to tell me, we don't have any numbers yet for the initial fence. We just kind of came up with ones. Tell me how you would find, so listen to this question here. How would you find the number of feet? So we have yards here. So how would you find the number of feet that make up the perimeter of this fence, of this playground? So the amount of fence that we would need in feet. how would you find the number of feet you would need for this fence? With the numbers that just made sense to us. You can use them if you want to. If you don't like these numbers and you just want to talk about any number, go ahead and do that. So let me ask that one more time. How would you find the number of feet that make up the perimeter? Think about what you know about perimeter. For those of you that maybe haven't heard that yet, don't worry about it. It's just a term that we use in math to talk about the lengths on all sides of a shape, the total sum. Okay. You would multiply by 3. Fantastic. You guys are very smart. I love it. Okay, so I see you would multiply by 3. I'll explain why that's a great comment in just a second. And I see the reasoning come up right now. 1 yard is just being shared with us in the comments right now. 1 yard is 3 feet, and so 10 yards is 30 feet. Beautiful job. Okay, so that's exactly right. So what if I wanted to find the perimeter? Again, if you're not used to that term, that's not a problem. We're just looking at how much total fence we would need in feet instead of the yards that we had initially. So that's exactly right. Depending on how many yards I have, I'm going to multiply that by 3. Because as you guys shared with me already, 3 feet in 1 yard. And that's going to give me the number of feet for my length and then my width. So to find the total perimeter, I have to multiply by, I think I'm seeing it somewhere. I think I saw double. No, I did not see it yet. Okay. So to find the total perimeter, I'm going to multiply. Or let me even put it this way. Let's say double. Let's say double number of feet of the length. Can I squeeze that in? Yeah. And adds to that double the number of the feet for the width. Oh, I can't squeeze that in. Let's say this. Double the number of feet for the width. And as you guys told me, we're going to multiply the yards times 3 to tell us how many feet we have. Okay? Double, for the student that's asking, means you multiply by 2. And if you're asking, why is it double? Well, remember what I said about the perimeter. So let's say we have this fence surrounding our playground. So let's say the playground is in here. This is the playground. We have 2 of the width and 2 of the length, or the other way around. Okay? Or you can add all 4 sides separately. Again, this is not a conversation about perimeter, but once you understand that you're finding the total of the fence, you know that there's 2 sides the same here and 2 sides the same here. All right? Perfect. And what if then I asked you for the area, just out of curiosity? So what if I wanted to know how much space is in here? How would you find that? How would you tell me that? Right? And don't get too concerned with the numbers here. So I see some of you are telling me the answer for the perimeter, which is beautiful. I love it. It's very clear when someone gives me the numerical answer that you guys just love to perform the calculations, which is great. I mean, that's why we're here. That's why we love math. But make sure you also understand why you did it the way you did. And that's why I love that some questions are coming in about the doubling. Well, why are we doubling? Well, because we have a deep understanding of perimeter, or we also have a deep understanding of how to find the total fence used. Okay? So let's say then I asked you to find the area. And Lorraine just asked another fantastic question, these are great questions that we should be asking when we encounter a numberless math problem, a math problem that doesn't maybe give us enough information that we need. And Lorraine is asking, well, what shape should the fence be? So you saw with the work that I did here, I assumed that it was a rectangle. I did, right? And I even drew it here, right? And maybe I didn't tell you guys that, but we were all under the assumption that it's a rectangle. But that's an absolutely fair question to ask, is what shape is this playground to start with, right? Am I actually working with a really cool triangular shaped playground, right? So I love that you're asking those right questions. Anything that makes you really wonder about the information, you should always feel comfortable to ask your teachers and your instructors is, what other information should I know to better perform this question? Okay, so what if I wanted to find the area, which is just the space inside? What would we do there? Let me maybe give you a few seconds to find that. Oh, I'm actually seeing an answer pop up. Is it a rectangle? Yeah, let's stick with it being a rectangle. Okay. Well, how do we find area? If you've seen this in the classroom, we take length and we multiply by width, and there's a whole reasoning behind that. So there is a lesson on area that you can rewatch if you need to on Mathnasium Schoolhouse. But to find the area of the rectangle, we multiply those two values. But if we want it in feet rather than yards, we're going to take those initial amounts and multiply by 3 before we multiply together. So we're going to do length in feet multiplied by width in feet. And don't forget to go from yards to feet, we multiply by 3. Or for my Canadian friends, if you had meters initially and you wanted to go to centimeters, we actually have a very easy calculation to do there, which is just to multiply by 100. So much easier. All right. So let me then ask you another type of numberless math problem. And you guys are wonderful. Multiply length times width. Beautiful. All right, so let me take this away. And again, I'm going to pose you with a numberless math problem, and I'm going to ask you to just reason out how you would find this answer. There are no numbers. Okay, who is Canadian? I'm sure there's some Canadian friends with us here, and maybe even more than outside. Great, maybe even outside Canada and the United States. So let's say I tell you that it is a quarter until the hour, right? And so if you think about, if it's almost 3 o'clock for me here, a quarter to 3 is 2:45, okay? So if you think about a clock, a quarter to the hour typically you can think is the previous hour and 45 minutes, okay? And let's say I still have to run a lot of errands. So I still have a lot to do, okay, before the hour comes up. I have to go to the grocery store, and then I have to go to the bank. Okay? Hi, PJ, and I apologize for, yes, your mom's name is Lorraine. Very nice. Well, thank you for asking wonderful questions today. Okay? So I have to go to the grocery store and the bank before the hour comes up. It usually takes me the same amount of time to go to the groceries. The time of day that I go, there's not as much traffic, so I'm good. But only half the usual amount of time to go to the bank. So what time do you think I'll be done with my errands? Okay. So first, if you listened to that statement, I think, okay, it's quarter to the hour. So as I said, we're just going to use X's to denote the hour. It's some hour and 45 minutes. Okay, that's the current time. I don't know exactly if it's 1:45 or 7:45. In fact, I don't even care right now. But this is what it is right now, quarter to the next hour, okay? And it typically takes me some amount of time to do my groceries. So I'm just going to write that. Again, I don't know how much time, but it takes me time to get groceries. So I know that once someone gives me this information, maybe I'm going to ask Larry to give me how much information, the information I need here, or maybe I'll time myself the next time I go get groceries and I'll know what to substitute here. But for now, I know that once I get this information, I'll be able to add it to the time that it currently is. And then it typically takes me half the amount of time to go to the bank. So I'm just going to recognize that this will be half the time it takes to the bank. Let's just say to bank. Okay. And so the beautiful thing here, I'll explain this one more time for those of you that find it confusing, is I didn't need the numbers to know what I'm going to do in this math problem. And believe it or not, this is a math problem because we're performing an operation on pieces of information. So if now I told you that, let's say it's almost 2:45 in my time zone, and it takes me, I'm going to really be optimistic here. Let's say it takes me 10 minutes to get groceries. That's a tad bit ridiculous. Let's say I only need some water. And then it takes, let's say, even half the time of the grocery time to go to the bank. And if you maybe tuned into the Schoolhouse lesson on finding half of numbers, you would know half of 10 is 5. So here it takes me 5 minutes. I know what to do with this information because it's just a matter of adding it up, right? We are working with time, so it just becomes a little bit more tricky, but that's okay. I purposefully chose numbers that would be nice to us. So if I have 2:45 and I add 10 minutes, I'm at 2:55. 5 more minutes, I'm at 3 o'clock. So right at the hour, I managed to get all my errands done. Okay. Yeah, so what I just did here, for those of you that are confused with the X, and this is maybe a great place to have this conversation, is this is where variables come into play in mathematics, right? For those of you that maybe started to see, maybe you have an older sibling and you start to see letters pop into their math homework, this is where we can start to add in these symbols to represent any number, okay? So as the comment there says, it could stand for 2, it could stand for 3, 4, 5, 11. I love that because that's true. Right? But the fact is, I don't care exactly what time it is right now. I just care to understand what I'm going to do with my information once I get it. Because I, as a math learner, know what to do with the information that's in my word problem. Okay? So let's see if maybe we can do 1 or 2 more before we end. So let's say, I'm going to erase this. Again, I'm going to just read out this word problem. I don't want to use up all our whiteboard space writing out the problem. So pay attention. I'll repeat it maybe twice. I have a friend. His name is Bart. And Bart is selling his old computer online. All right. He measures the screen to the nearest fraction of an inch. Okay. Again, I don't have any numbers yet. He's just measuring it. And then a buyer asks him how many centimeters the screen is. Ooh, okay. So this is where it gets a little bit tricky with the units of measure, but I'll help you out with that in just a second. So how many centimeters should Bart tell him that the screen is? He knows how many inches there are. How many centimeters should he tell him? What do you think? He has a screen. He's measured it to some estimate of an inch, some fraction of an inch. But the buyer cares to know about the centimeters, not the inches. How could Bart reply back to this potential buyer? What? And rather than telling me the exact answer, because that's not the purpose right now, tell me, what information do you need? Beautiful. And there we go. So PJ is asking another fantastic question because she's already thinking, okay, Sandra gave me some question, right? But there's not enough information there for me to actually give her an answer right now. I want to know, as PJ points out, how many inches did Bart find? Maybe that'll help me better understand how many centimeters, right? And I'm going to say absolutely, right? Let's say that I told you, I don't know, Bart whispered to my ear and said it's, 7 inches. I'm just pulling out any number. That's a very small computer screen, but that's all right. So let's say it was 7 inches. What would you want to know after that? And we need to know this, right? Let's see if I can squeeze in this very long metric word. Centimeters, got it. All right. What else do you need to know to help Bart answer this potential buyer? What would you turn to me to ask, or your teacher? What other information would you want? And hopefully what you're asking yourself, I don't see it pop up yet, but if I do, I'll definitely acknowledge it, is, well, Sandra, I don't know how many inches make up a centimeter or the other way around, right? I don't know what I have to do to find how many centimeters this would represent, right? It's not like yards to feet where I knew there were 3 feet in 1 yard, right? There we go. So how many centimeters is it? Yeah. And maybe what you meant is not even the full centimeters at the end of the problem with the solution. There we go. How many centimeters equals an inch? Perfect. That's exactly right. That's the information that we need. So you could do it a few ways. You could go onto Google and try to just research it and find that answer. But if you're stuck in a classroom, you could just turn to your teacher and ask them to help you out, right? But that's exactly right. Those are the questions that we need to be asking ourselves. Perfect. So I said 7 inches, so you convert it to centimeters. I love that you use that word, right? That's exactly right. So can anyone tell me? Let's see. I'm going to pose the challenge to you. Who can tell me, what do I have to multiply by here? We're going from inches to a completely different system of units of measure. What do we think? I'm watching the comments, seeing who shares that with us first. What do we multiply by? 2.5 I see show up. Yeah, that's right. 2.54 is typically what we stick with, but I'm going to take that. Thank you, Shimmy. And if you are on your parents' account, definitely feel free to share with me what your name is. But that's right. So I would take this amount, and I don't have to do the math right now. That's not the point of today's lesson. But I would multiply this amount by 2.54. Beautiful. Okay. So hopefully you've started to see the value in taking a math problem and removing the numbers sometimes, right? And before I end off, I'll just show you, for some of you that are maybe in 2nd grade, a more approachable problem for you. So what if in the classroom you're posed with this problem? Let's say we go back to, let me pull up maybe a better one. Okay. Let's say I have, and this is very relatable to me because in my backyard I have a bunch of mosquitoes. So let's say that I have 10 mosquitoes. All right, so this is the word problem that you're posed with, let's say in your homework. There are 10 mosquitoes around a pond. Okay. You have a frog there as well, and the frog unfortunately catches the mosquito. It's hungry and it wants to catch some of them, right? So let me just write that down. Frog catches some. I apologize for the short sentences there. So the frog catches some. Now there are only 7 mosquitoes. Okay. So how many mosquitoes did the frog catch? So for those of you that see word problems, and don't be afraid to kind of tell yourself, you know what, this is me. I don't like word problems. It's totally fair, right? Sometimes when we're telling a story behind a math problem, we use a lot of words to tell that story. And so it looks possibly pretty intimidating, right? We look at this lengthy problem, and sometimes it's not apparent to us what exactly we should do with this information. And so what I hope you get out of today, whether you're in 2nd grade or 7th grade, is that on top of some of the problem-solving strategies that you've learned from your teachers, which is to identify some of the key terms, let's say something like that, identify the key terms, you also might want to remove some of the numbers, right? So here I have a 10, but maybe I don't want to focus on the 10 right now. Maybe I personally don't like numbers, and they they scare me a little bit. And right now I just want to understand what I have to do with this information and ignore the numbers for now. So what you could instead do is say, okay, I have some mosquitoes around a pond. I don't know how much. I don't honestly want to do the subtraction or addition or multiplication, division, whatever's going to happen right now. There are some mosquitoes around a pond. Frog catches some. Now there are, let's just say some again here. I don't know. Or if you could think of a better word, share with me. Okay. So what you can do for yourself is remove the numbers and now start to think, okay, so I had some amount of mosquitoes around a pond. Let's say this is my pond. I had some amount of mosquitoes there. Sorry, that was cut off. Okay. But then a frog, and I'm not going to try to draw a frog here. I'm just going to say with the little X here that that's my frog, catches some. And so now there are only, let's say, this many mosquitoes left over. Okay. So now, how do I find out how many mosquitoes the frog ate? Well, what if I take how many I had in the beginning and I see how many I have at the end, and since this is smaller than how many I had in the beginning, I believe I have to subtract, and that would be correct, right? So there was a large amount in the beginning, now there's a smaller amount, so I would subtract, and that would be how many mosquitoes the frog ate. So going back, I like that emoji there of the frog, that's really cute. So going back, what if I had, what did I say, 16 or did I say 10? I said 10, right? And then I think there were 7 here. I see someone saying dragonflies only eat mosquitoes. That's cool to know. Now that there are 7 mosquitoes left over, how many did the frog eat? I think I saw it earlier. The frog ate 3. Okay? Or the dragonfly, if that makes you happier. All right? I'm going to end it there for you guys. We will have a worksheet available for you after this lesson later on today with some more numberless word problems that you can practice. And what I'll do also in that package is give you numbered math problems, so math problems with numbers, that you might find useful to find the solution to if you actually remove the numbers. And I might give you some suggestions in there as well. And if you're interested in more of these, reach out to your nearest Mathnasium. We have many, many of these problems that we can share with you. And I absolutely encourage you to train your math muscles to think this way. I think it's a wonderful strategy to something that a lot of students do find challenging, which is solving word problems, okay? So if you fit into that category, honestly, you're not alone. Like I joked about earlier, people like to say math complicates things. I'm in the group of people that say, you know what, it's sometimes English that does that. And so sometimes what we want to do is either add numbers or take away numbers, depending on the situation. So I hope you guys have a wonderful rest of your day. I hope that you learned something new from here. Maybe you can share in the comments anything that you're interested in learning about in future lessons. All right. Have a wonderful day, and we will see you on tomorrow's next lesson. Bye-bye.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.